Okay, hi all. Thank you all for joining. I guess we're ready to start. So I'm going to be presenting an empirical approach to making your application a one-hour project. So my name is Yola. I'm a software engineer at Goldman Sachs. I'm a full stack developer, and I've been with Goldman Sachs for around 5 years now. And I just wanted to share with you some of my experiences when it came to software development, speaking with users, and making that process as efficient as possible. So let us start. I'm going to start with going over the agenda first. So firstly, let's start with explaining the title. And the obvious. Then next, I'll introduce you to a sample we'll be using for some of our use cases. Then we'll go through the product enhancement cycle. So basically speak to what process to best follow to get to the efficient solution. And then we'll just have a quick summary at the end. So let us begin. Okay, explaining the title. An empirical approach to making your application a one-hour project. Empirical approach, let's focus on that first. Empirical means verifiable by observation or experience. So rather than assuming something or thinking that a user needs a certain feature, certain solution, we're going to actually have some proof of it. So verified by observation. The next point I want to bring your focus to is the one-hour project, which means here that from start to finish, you can complete all required tasks in 1 hour. Let's not focus on that 1 hour here, but rather the fact of making your application more efficient in a certain amount of time. So if you think of a tool like PowerPoint, you are likely to take a lot more time creating your presentation than 1 hour. So let's say 3 hours. But in that 3 hours, we want to make it more efficient and make it faster for you to do more in those 3 hours. So from start to finish, we're going to improve how much you can do in those 3 hours. So let's continue on. Why is the topic important? You might have seen this comic before. I think it's very common when talking about requirements gathering. So we have a customer. A customer is explaining a requirement of a new feature that they might want. So the tree here, let's assume that's our application. And the customer comes to us and says they want to add a swing to our application, so to our tree. Now, I think the important thing to note here is that everyone is different. Everyone thinks differently. We have different experiences, we have different backgrounds, and interpret things differently. So if we've only had one communication with our users, we might interpret the requirement differently. So let's take a look at the first example. The project lead has understood the requirement as a swing in front of the tree. That might not make sense, but if that's what the customer wants, we're going to develop it, right? Another good example I really like is the business consultant with the couch on the swing. They always interpret everything as over-exaggerated. It might be cool, it might be nice to have, but it might take longer to implement. It might not be actually what the customer wants or needs. One final part of the comic I want to bring your attention to is the final one, what the customer really needed. So throughout the development lifecycle, you often find out that a customer actually doesn't really know what they need. They know something is wrong, they know they want an extra feature, but what that is, they might not be aware of it. So it's important to keep that communication going to ensure that the final product is actually what they need. Let's take this a step further. What if we remove further even the first step? So we remove the fact that we even speak to our customer, right? So what if we haven't had that conversation even at the beginning? We might be just assuming what the customer needs. So imagine how these different comics will further change. So the project lead might, for example, then think, oh, I'm sure they want also the couch and swing. Or they might be thinking totally different. What if they're thinking, oh, potentially my customer doesn't need the shade under my tree. I'm just going to cut the top of the tree off. But then the requirement comes that they want the swing, and we can't add the swing because we've cut the top of the tree off. So it's important to have a constant communication feedback loop. So let's continue on. What if? So what if we have no communication? What if we have no continuous feedback loop? What if we don't research our requirements or our design? What if we assume versus confirm? That will likely result in the feature being, for example, unintuitive, the feature not working, the feature being potentially even not required, or it being different from expectation. And that could result in the negatives, like throwaway work. We've done extra work, we spent on it 2 months, but actually no one needs it. This results in an unsatisfied customer, but also an unsatisfied developer. Developers also are also much more satisfied with their work if they're creating something that is useful. And then extra clutter in your code. And so it might make it less easy to read. It might just spam it up a bit. So let me introduce you now to the sample application that we'll be using and trying to improve based on some empirical observation. So this tool is called IgnitePad. So we're developing it in our company. And the idea is that it's a self-service tool for our users to do data manipulation. So you can imagine, for example, in Excel, you've got 1 million rows and you're trying to combine columns, combine cells, do some addition, subtraction, all of that. So we're trying to allow users to do that in a self-service manner, in a much more controlled manner in this tool. For example, in Excel, you're likely not going to be able to do data manipulation on, for example, 1 million rows. So here we're trying to enable that. So here, if you look at our tool, we've got the yellow blocks, which get data. We've got the blue blocks, which do the data manipulation. And then we've got the dark blue blocks, which then output the data back, for example, into a database, wherever you got the data from. And in the left-hand side, you have got your library, so you can drag and drop these elements into your program over here. One feature of the application I want to bring your attention to is the debug mode. So as you run your program, so here you click on the run and capture, you execute your data manipulation. So you start doing the manipulation however you set it up. And on each node, we capture the data. So a user can come in and they can view the data on each point and see whether it's what they expect. Right? So here at the bottom, you can see that on this port, on this output, I've got this data. And I can decide on whether that's what I want to do. I can make some changes in my program, rerun it, and see enhancements. So this is how I see development, what I've been doing. And as part of my development of my feet, we're going to go one by one through ensure efficient solution. Start with the problem. So figuring the problem actually is the feature. So how do we do that? So here it is important watch your users see how they work, right? So you can shadow your user. For example, you can go and sit with a user and see what they're doing. See where they might have pitfalls, see where they might be doing something differently to what you initially expected, see whether they might be getting stuck or where things might be taking longer than expected. Another approach is to record a user's work. So give them a task. Give them a task to complete a certain data manipulation. Let them connect those different blocks together, set the different parameters, and record what they're doing step by step. Recording is good because you can always go back to the different sections of the user's work and see specifically what they did at what point of time, rather than trying to write it all down when shadowing. Another approach is surveying. Send a user survey, right? Try and find out what they think, where they are having problems, what they think they might need help with, what features they think they would want to improve, what maybe they like about the application, what they don't like. Here also, this might be very valuable input. And finally, become one of the users. I think we often forget when developing applications that we don't actually try and use the application. When you try and use the application, you will automatically find things that might be not as intuitive as you thought initially. So try the application out, try and build a program, do your own data manipulation, and see where things might be more difficult than initially expected. So now I'm going to take you through an example where we actually did a study and actually gave a set number of users a task to complete and recorded all of their actions. We then looked at all those recordings and summarized the results. So over here, you can see our empirical study. And we found that users were spending different amount of time on different parts of the tool. So here, for example, 39% of their time in building their program was spent on configuring those data manipulation blocks and actually dragging and dropping them into the program. So that was taking more time than we initially expected would be the case. Another example is reviewing the output. 20% of a user's time was spent reviewing the output. So looking at the table at the bottom and seeing if their data matches with their expectations. So for these different areas, focus areas, we can now start looking more into detail and seeing how we can improve and decrease that 39% to, for example, I don't know, even 30%. Anything that will make the user's life easier. So we're gonna look at reviewing the output part of the application, and we're gonna go through an actual study, case study, where we saw a user looking at their output. So here, have a look. This is a sample recording. So you can see the user at work. They're viewing the data, they're looking at different data points, different numbers, seeing what their output was. Let's see what happens next. Now they're going to the home screen. They're going to switch to a different execution at an earlier time. They're going to select their node. And again, they're going to be looking at the data that was output at that node. So you can see they're looking at data from one execution and looking at data from another execution. Now they went back to the home screen and back to the first execution again. So back to the original execution. And again, comparing data. So what issues do you think you can see in this view? What is the problem? Let's try and identify what problems we saw during this recording. And that's exactly what we did. So we found that the user loses time to switch between the views. You saw that they were looking at the data and then they had to go to the home screen, they had to select the execution they wanted, they had to select the node that they wanted, and only then look at the data. They switched again, views, they had to go through that process again. So that took them 4 clicks that could be shortened. So they lost time doing that. Another problem we identified was that the user was losing context between the data. We saw the user be in one view, go to a different execution, look at the data, and then go back to the original data execution. So again, because they might have forgotten what they were initially looking at, they want to compare easily the data between executions. So they lost context when they were doing the whole switching. So what are the requirements of this feature? What does the user want to do in this feature? So they want to compare easily 2 views, so 2 executions. They want to have an easy way to view the differences between the data. What's another requirement? To easily switch between the data. So switch between the different executions. So now we go to the part of the cycle where we want to propose solutions. Note the S. So we're not going to be proposing a single solution, but we're going to be proposing multiple solutions because there will be a number of ways how we can address these problems. So let's go to propose solutions. So this is our original view. Let's now add some extra features. So this is the feature number 1. You can see it over here. So this is the new feature. So we've added some arrows up and down to switch between the different executions. We've added the timestamp of that execution. So over here, you can see when this execution that we're looking at was run, and then some extra information. So for example, if you're viewing an execution that happened earlier in the day, it will tell you that this execution is an old execution. So be aware that you're looking at old data, just to give some extra information. So this is solution number 1. Let's go to the next solution. A next solution is on the execution screen. So we have execution 1 and execution 2. We're going to add extra checkboxes. So these are the new checkboxes. And we're going to add an extra button, which says compare data. So once a user would check the checkboxes, click on compare the data, we would show a diff view. So we would show both executions in one view, only showing the differences. So in this example here, for example, the red dots and these rows here show that the data now doesn't exist anymore. So it's missing. So it has been removed from the data. However, this, for example, row here and this cell shows that the word Hong Kong has changed to Warsaw. Okay, so here, this will be an easy solution for someone to compare between two views. Let's look at another solution. This solution here, we have suggested to add a timeline to our executions. So a user looking at their execution can select between the different executions, can click on the timeline, and quickly switch between the execution for this node. So if I had 5 executions, I'd have 5 dots on the timeline here. And we would limit that to, for example, 7 executions so that the timeline isn't too large. So now that I've got 3 solutions, how do I decide which solution is the best for our requirement? And this is where the users come in. And this is a very important step. We're going to test each of these solutions with our users, present them to our users, and see if they make sense. One important thing to note here, you don't want to just go in and show them the solution and show them how it would work. The important thing here is to go to the users, show them the solution, but then ask them, what would you expect to happen if you click on a certain button? What do you think this timestamp means? What do you think this information is making you aware of? This will allow for you to see what parts of the feature are intuitive, are not so intuitive. So for example, the user will say that the timestamp means that it's the time of for example, time now, rather than the time of the execution. Might not make sense, but that might be what they're thinking, right? The checkboxes, they might be very separate. They might not know why the checkboxes are there. Maybe in that case, we need to add some kind of extra information to guide the user to those checkboxes. So you speak to users, you show them the solutions, you figure out what is intuitive, what is not so intuitive, and you improve those solutions. A very important thing here is, after you improve the solutions, you go back to the users. Again, test whether the changes you've made have made it more intuitive, make more sense. And again, if you get more feedback, improve the solutions again. You can continue in this cycle until you and the users are satisfied with the product that you've come up with. Next, we want to select the solution, right? We have 3 solutions, but we're not going to be implementing all of them, right? So we have to figure out which one makes most sense. And again, this is important to make with your user. You shouldn't be, again, assuming which one makes most sense. You should be deciding this with the user, and the user should be telling you which solution makes most sense. So in this example, with the user, we decided that the timeline makes most sense, right? The compare view would have been useful for looking only between 2 executions and having a more detailed view. However, that would have, again, taken too much time to go click on the checkboxes, compare data. And if I want to switch between executions, I again have to go to the home screen, again, switch between executions, select different. As you can see, it's very time consuming. We found that the user just wants to very quickly switch between executions. So we have our feature that we are gonna be implementing. But when do we implement it? As you saw during our empirical study, we had a number of areas that we wanted to focus on. So we had, for example, 5 areas we were focusing on, 5 different solutions we selected for different parts of the program implementation cycle. And now we have to decide which solution is most impactful, which feature are we going to be improving first. And that is where prioritization comes in. So this, again, should be done with your user. We're going to be prioritizing the different 5 solutions we have come up with, and we're going to decide which feature to implement first. Because if we have 5 features, if each feature takes a month, then all of the features will be completed basically in about half a year. And imagine new requirements coming in the meantime. Potentially, we'll never get to that fifth feature, right? We want to make sure that the feature that we're implementing from the start is the one that is most useful. So how do we prioritize? First, we're going to decide on what is the average time spent now on the feature. This we will have from our study, from our original study. Then we're going to estimate the time saved after the feature is implemented. So this will have to be an estimation from our end. Once we implemented the feature, how much time can we decrease in the time spent, right? So if we go back to our timeline, we can remove all of the time that was spent on switching between executions, right? So that will be our time gain. Then we want to also estimate the effort for implementation of the feature, okay? So here this is important because some features will take a day to implement, some features will take a year to implement. We have to also specify that because that could also determine priority. And then how important is this for the user? How much impact will the feature have for your user? So let's look at our example. We have 5 different features. So our one that we looked at was, for example, the easier data comparison. And then we had 4 others that we've come up with in the same way. We have the average time spent, we have the time saved, and the estimated effort. Different estimations, it's a good way to estimate them using t-shirt sizes. What that means is using tags like small, medium, large. Because in effect, it is hard to estimate what the actual effort spent will be, especially very initially in your implementations. But here we at least have the relative comparison between features. Next, this is the part where the user comes in. They're going to be telling us what impact each of these features will have. So the users comes in, and again, they use a t-shirt size estimation to help us identify how impactful each of the features will be. And now we prioritize, again with the users, when do we implement each of the features. And as we can see, the feature with the most impact and smallest effort is our first feature here. So likely this will be the first feature we implement. Next, we have 2 items with green impact and effort. One of them has got high impact, one of them has small effort. Right here, the one with the higher impact will likely be more important for your user. So likely this second task will be the second one that we will implement, and so on and so forth. Here, this one is medium impact, but also large effort. So it might make more sense to implement something that the user might get faster, but is as impactful. So we prioritize each one by one, from 1 to 5. We set the priority. So the first implementation that we're going to be looking at is easier data comparison. Now that we have our prioritization, we can start implementing our feature. An important thing here, again, ensure before you do the implementation, you have all of your designs done. Most of them you should have already done during your proposing of the solutions. There's not much point proposing a solution, which then we find out isn't actually possible to implement, right? Maybe the timeline feature, we can't get out of the box, we're going to have to implement it ourselves. So these kind of things we have to also decide before we actually do the implementation. Let me show you now the final feature that we implemented to show you what impact it had. So here you can see we've got the timeline. A user now can compare the data easily. They can change the widths of the columns. And then very important to note, those widths of columns will also stay constant between the executions. So a user doesn't have to, between each view, set those widths once again. They stay constant between executions, and they can easily flip between one and the other and see the difference between the data. So this is now in our tool in production, and it has been saving a lot of time for our users, and it has been a feature that they do actually use. So our investigation was successful. So now just to summarize, very quick summary. Basically, I would recommend just following the cycle. When you're doing your feature improvements, feature enhancements, follow the cycle, identify the problem, identify the requirements, propose different solutions, ensure that the user understands the feature, and if the feature makes sense, right? Make any improvements to it after you get the feedback. Then select from the multiple solutions the one that you actually think will be most effective. Again, speaking with the users, prioritize the different features you might be implementing, or if there's only one feature that you're implementing, easy job done. You can skip this step. And then you're ready to design and implement. And that will be all from me. Thank you very much. Thank you for listening. Hope it was useful. And thank you very much.